try to imagine nothing. Absolute nothing. Not darkness, that's something. Not empty space, that's something too. Just nothing. Pure void. You can't do it. Your brain refuses. And here's the strange part. Nature refuses too. There is no such thing as nothing. There never was. The space between atoms, the space you thought was empty, is actually the busiest, most energetic place in the entire universe. You're sitting on a chair right now, or standing on a floor. It feels solid, continuous, real, but you know it's made of atoms, and atoms are mostly empty space. If you scaled an atom up to the size of a football stadium, the nucleus would be a marble at the center, and the electrons would be specks somewhere in the outer stands. Everything in between appears to be empty. So when you sit on that chair, the atoms in your body and the atoms in the chair never actually make contact. There's space between them, always. You've never touched anything in your entire life. And yet, you don't fall through the chair. Something in that empty space is holding you up against gravity. What is it? Subscribe and like for more videos that explain what's really happening beneath the surface. Because what's between the atoms is far stranger than the atoms themselves. Your intuition says nothing. Just empty space, and somehow atoms repel each other through that space. But that's not an explanation. That's just describing what happens. How does one atom know another atom is nearby if there's nothing between them? How does the force travel across the void? Here's where we need to be careful. When physicists say empty space, they don't mean nothing. They mean space with no particles, no atoms, no electrons, no photons. But that space isn't empty. It's filled with fields. Electric fields, magnetic fields, quantum fields. And fields are as real as matter. They're not mathematical abstractions. They're actual physical things that exist everywhere in space, even when there are no particles around. Every electron, every proton carries an electric charge. That charge creates an electric field around it, extending infinitely in all directions, getting weaker with distance, but never reaching zero. The field is there, whether or not there's anything to feel it. When another charged particle enters that field, it feels a force. The field pushes or pulls, depending on the charges. Like charges repel, opposite charges attract. But the key insight is this: the force doesn't travel directly from particle to particle. It's mediated by the field. One particle creates a field. Another particle responds to that field. The field is the thing in between, making the interaction happen. When you sit on a chair, the electrons in your body enter the electric field created by electrons in the chair. Those fields push against each other. Electric field repels electric field. That repulsion, that force you feel as solidity, is the electric field doing work. You're not touching the chair. You're being held up by overlapping electric fields that refuse to let electrons get too close. And these fields are everywhere. Right now you're surrounded by electric fields from every charged particle nearby. The walls, the air, your own body, all permeated by overlapping fields. Space is not empty. It's a thick soup of fields. But it gets stranger. Even if you removed every particle from a region, every atom, every photon, every bit of matter, the fields would still be there. Quantum field theory tells us fields exist independent of particles. In fact, particles are excitations in fields. An electron isn't a ball that creates a field. An electron is a localized disturbance in the electron field pervading all of space. A photon is a ripple in the electromagnetic field. Particles are disturbances in fields, not separate things alongside fields. Now here's where it gets truly weird. Quantum mechanics says fields can't be perfectly still. Even without particles, fields constantly fluctuate. This isn't measurement error. The fields genuinely jitter, vibrate, fluctuate at every point in space, at every moment. This is quantum vacuum fluctuation, a consequence of Heisenberg's uncertainty principle. The uncertainty principle says you can't know both a field S value and its rate of change with perfect precision. If a field were perfectly zero, perfectly still, you'd know both exactly, which quantum mechanics forbids. So the field must fluctuate. It must have minimum energy even in its lowest state. That's called zero-point energy, and it's everywhere. This means the vacuum, the space between atoms, between galaxies, the space you thought was empty, is seething with activity. Virtual particles constantly pop into existence and annihilate in incredibly short timescales. Particle-antiparticle pairs appear from vacuum, exist briefly, then disappear. This isn't speculation. It has measurable consequences. The most famous is the Casimir effect. Take two uncharged metal plates and place them close together in vacuum. They experience an attractive force pulling them together. No charge, no magnetism, no gravity explains it. What happens is vacuum fluctuations between the plates are restricted. Only certain wavelengths of virtual photons fit in the tiny gap. But outside the plates, all wavelengths exist. The vacuum outside pushes harder than inside, squeezing the plates together. Empty space pushes on objects. The vacuum has pressure. Nothing has physical effects. Let me be clear what this means. The space between atoms in your body, between the chair and you, between stars, none of it is empty. It's filled with fields constantly fluctuating. Particles appear and disappear billions of times every second in volumes smaller than atoms. The vacuum isn't passive. It's dynamic, energetic, and participates in every physical process. You might ask, if virtual particles appear constantly, why don't we see them? Because they exist for such short times, they can't be directly observed. The uncertainty principle lets them borrow energy from vacuum briefly, but they must pay it back almost immediately. The more energy borrowed, the shorter they exist. But while they exist, they have real effects. They contribute to real particle properties. They affect how particles interact. They create forces like the Casimir effect. Here's a mind-bending fact. When you calculate the vacuum as total energy density, the energy in empty space from quantum fluctuations, the answer is absurdly large. Some calculations give 10,120 times larger than observed. This is the cosmological constant problem, one of physics' biggest mysteries. We don't know why vacuum energy doesn't tear the universe apart. There's something we're missing about the vacuum's nature. But what we do know, the vacuum is not nothing, not empty, not passive. The vacuum is a physical system with structure, energy, and dynamics. It's the stage where reality plays out, but it's not passive. It's an active participant. So what's between atoms? Fields, electric fields, magnetic fields, quantum fields of every type. And those fields never stop. They fluctuate, vibrate, seethe with virtual particles, existing for the briefest instants before vanishing. The space between atoms isn't empty. It's full, impossibly busy. This leads to a philosophical point Feynman loved. Nature doesn't care what you think makes sense. Your intuition evolved for everyday objects at everyday scales. Rocks, trees, people. Things moving slowly, large compared to atoms. Your intuition has no business being correct at quantum or cosmic scales. And it isn't. When you probe nature carefully, trust experiments over expectations, nature reveals itself far stranger than anything you imagined. Space between atoms isn't empty because nature doesn't allow true emptiness. The uncertainty principle forbids it. Quantum fields fluctuate. Virtual particles appear and vanish. The vacuum has energy, structure, physical effects. You can't have nothing because nothing is unstable. Given the slightest opportunity, quantum fluctuations fill the void. Something emerges from nothing, borrows energy, exists briefly, vanishes. That process never stops. It's happening now, everywhere, always. You've never touched anything because there's always electric field between you and everything else, holding you up, pushing you away, keeping electrons from colliding. You float through life on a cushion of electric repulsion, mediated by fields filling every cubic centimeter of space. And those fields are never quiet. They're the loudest, most energetic part of reality, hidden from your senses, but fundamental to your existence. That's what's between the atoms. Not nothing, everything.